Yeah, we can see it.
Okay, awesome. All right, so what are we supposed to do today?
Find the U moving.
Yep, and how would we do that?
Divide feet by minutes.
Correct. So it shouldn't matter which one you use. No matter which one, we should get how much?
24.
Yep, 24 feet, not feet, per minute. Okay, so that is what your answer is. Okay, make sure, guys, you are showing your work. Okay, so 24 feet per minute. All right, put those up, and you should have lesson 9-2. 9-2, which is page 301. 301. And if you have your protractors and compasses, you need to have them out. If not, then you'll have to follow along. All right, so we're missing one person. Who are we missing? Not Spalding. Singleton, is Jaden here? Oh, I see Jaden, so we're not missing Jaden. Okay, I see Tyrone. I see Layla. Oh, I know who it is. Yeah, okay, we got it. All right. So we're going to draw and construct triangles given side lengths. So unlike in 9-1, we drew a circle and they told us to draw a triangle inside the circle. Most of the times we didn't have given side lengths. We just knew that it had to be a certain degree, had to be obtuse, it had to be something. Okay? All right, so your objective is to determine whether 3 lengths could be side lengths of a triangle, and given 2 side lengths, I can find the range of possible values for the 3rd side. All right, so Martha is drawing a wind chime. She has pieces of metal pipe that are 2, 3, 4, and 5 that she is going to use to make a triangle top for the wind chime. Which combinations of the 3 lengths will not work to make them? They go up there, sweetie. Not work to make. Sorry. What 3 lengths will not work to make the top? So I am going to make a little table so we can kind of keep track of what we're doing, right? So side 1, side 2. Side 3, and does it make a triangle? All right, and so the first one I am going to try is a 2 by 3 by 4. So a 2 by 3 by 4. Okay. Then I'm going to do a 2 by 3 by 5, and then a 2 by 4 by 5, and then the last one will be a 3 by 4 by 5. Okay, so those are the only ones that we can make given those side lengths. All right, and so I'm going to make this side 3 always be the base. Okay? All right. I'm using the centimeter side just because if we use inches, the triangles are going to be huge. Okay? So try to use your centimeter side. All right. So the bottom is 4. So I'm going to draw from here to here a side length of 4. There is a Mountain Dew chase in the refrigerator if you want a Mountain Dew. Okay. All right. And I don't know why I put that up there, but it can go down here. All right. So The other two side links, you're going to have to kind of play around with the diagonals. Okay? Because even though it may be, let's say 3, right? So if this is my 3, I can either make my diagonal there. I could make my diagonal look like that. I could go a little bit further and make it look like that. So I have to play around with the diagonals to see if I can get the side length of 2 to work. So I'm just going to kind of temporarily draw a light little line. And this is going to be 3. Then I'm going to see, well, can I get 2 to connect? And I did. Well, I don't know if I could do that again if I tried. Okay? So then that would be a 3 by 2 by 4. Okay, so as you can see, does it make a triangle? Yes.
Can you show me the picture so I can know which lesson it is?
Looks like it's got wind chimes. And it says draw and construct triangles given side lengths. Should be 9-2. All right. So the second side, my base is going to be 5. Okay, with a side length of 3 and 2. Okay, so once again, it's going to kind of be a little bit closer to the line, right? Because it can't be way up here and have a side length of 2. So I'm going to kind of slant it this way. So there's 3. And then this is where 2 is. All right, so let's think about that. 3 is way up here, right? I'm going to make it a little bit darker so you can see it. And here's 2. And 2 would go there. So if I continue to slant it, right, here's where 2 is going to end. Will I ever hit 3? So I could even go as far as probably down here. So there's 2. And let's say if I redraw 3, right? So if I take my 3, it's going to be close.
I don't think it works.
Yeah, it'll be close, but it will not work. So this is 2, and this is 3. So as you can see, it's missing that basically inch that we added down here, right? Because we added 5 here, but kept my side lengths the same. So it's kind of missing that little piece that we added. Okay? So it does not make a triangle. No matter how I try to adjust that length. Okay? All right, what do you think about 5, 2, and 4? So if I draw another 5 down here, and then I draw a 4, so once again, because my one side length is a 2, right, I'm not going to be able to slant it pretty high. It's going to have to be kind of lower. So I'm going to try it there and see if that works. And then let me try, so this would be my 4, and then let me try my 2 here, right? Yep. So that one works, right? So go back up here and write yes. So 4, 5, and 2. And then the last one, once again, draw a 5. And then it's going to be 4 and 3. So my 4 doesn't quite have to be as slanted. I can make it slant up a little bit more. So here's my 4. Not sure if it'll be that high. Let's go maybe like that. Let's see. Okay, so there's my 4 maybe. And let me try my 3. Whew, I don't know if I could do that again if I tried to get them that close together. So 5, 4, and 3. Okay, and then of course up here you would write yes. Alright, so 3 of them worked, 1 of them didn't. What do you notice about the ones that worked versus the one that didn't? Does anybody notice anything?
To have a triangle, one of the sides have to be like close to the longest side.
Okay, close, very close, Reagan, to that rule. So the 2 shortest sides, let's write it down here. So the 2 shortest sides, when added together, have to be longer, or has to be longer than the third. Okay, so if we go back up here, I'll start with this one so y'all can copy. This one would be 4 plus 2, which is 6. So 6 is greater than 5. I hear you, Xander. All right, so if we do this one, 4 plus 3 is 7. So 7 is greater than 5. So that's why they work. And then if we go up here, 3 plus 2 equals 5. And this is why it doesn't work. So it can not equal. It has to be more. Oh, I don't know. It should have been 3 plus what? 3 plus 2. My bad. And then we know this one works, right? So 3 plus 2 is greater than 4 because it's 5 is greater than 4. All right, so let me zoom out because I know I got a lot of information there. And those of you that need to copy, take a few minutes to get it copied. Whoop.
Do you think it would be put together if you lowered it just enough?
This one?
Yeah.
So what would happen is yes, but if I lower it any more, what's going to happen is it's going to sit on that line, and it wouldn't be a triangle at that point, right?
Uh-huh.
So that's why it doesn't work. It's because 3 plus 2 equals 5, and it basically just forms this line.
Okay.
Yeah.
Well, I mean, Miss Lavelle, there is another way to get it a little bit lower. It would be really, really, really hard to find which is a
It would not make a triangle. It would not make a triangle. If I take the 3 and the 5 length, right, and I bring them together to where they meet, they can only meet to form that line because 3 plus 2 is 5. So it gives me a straight line. It will never create a triangle. It will only create a straight line. Okay? No matter how far down you make it, it will just bring them together to form that straight line. Okay? I'll try to find a like a graphing thing to where I can show that to you. I'll have to find a website that does it because I know there's some out there. All right. So let's build some more understanding. All right. So once again, they're giving us 3 side lengths, 3, 8, and 4. So can we draw a triangle with side lengths 3, 8, and 4? So it says we can, if you have straws and stuff at home, that would work as well. So if you had some straws, Jaden, and you cut them in those lengths and put them together and move them, you would see what I'm talking about. That when you put them together, it form a straight line. Okay? All right. So it says use the longest side of your model as the possible base. Use your model to view the shorter sides in different positions. Can you draw a triangle? If so, draw one. If not, explain why not. So, before we even draw, what was the rule?
The shortest lengths have to, added together, have to be more than the longest.
It has to be more than the longest. So if I add 3 plus 4, is that greater than 8? No, it's less than.
No.
So that right there should tell you that there's no way you can even draw any of these triangles. Okay? So we're going to put for A and B, not possible. And the reason why is 3 plus 4 is less than 8. There's no way it's going to work. And then that's what we're going to put here for C. The sum of the lengths of the 2 shorter sides is less than the length of the longer side.
Is there a name to the rule?
Not that I know of. Well, it may be called the triangle theorem rule. If there is, they don't tell it to me in this book. But now that you say that, though, I think there is. I don't have 9.3 in front of me. I want to say it might be the triangle theorem.
I looked up the triangle theorem into Google, and the only thing that came up was the Pythagorean theorem.
Oh, yeah, that definitely isn't it. Rule for... Try rule for creating triangles. There it is. The triangle inequality theorem states that the sum, here you go, it's a theorem. I'm going to slide it over so you can see it. So can you see it? So it says the triangle inequality theorem states that the sum of 2 sides of a triangle must be greater than the measure of the third side. In other words, as soon as you know that the sum of the 2 sides is less or equal to the measure of the third, then you know that the sides do not make up a triangle. So there you go. It's called the triangle inequality theorem. So let's write that down. Theorem. All right, so there it is right there. Triangle inequality theorem.
Is there any exceptions to this rule?
So, yes. Well, yes and no. So the problem is Sometimes they're just going to give you 2 links. And then, so for example, let's say they give me 4 and 18, right? So we know that means that these numbers here for my third number has to be something larger than 14, right? Because 14 plus 14 is 18. So it would have to be anything larger than 14. So 14.1 or higher, right? But what if we make 14 the third side? No, I'm sorry. If we make, trying to think how we do this. So if I make 4 plus 18 the 2 sides, right? Now it has to be something larger than 22, right? So does that make sense?
It does.
Yeah.
Thank you.
So it would be a range of numbers anywhere between 14 and then anything larger than 22. So we're gonna there's one of those on the check understanding that gives us that range. Okay? So yes, there is some exceptions where you'll have a range of values. Okay? All right. So let's look at number 2. So number 2 says, can you draw a 3, 4, and 6 triangle? Well, so let's double check. 3 plus 4, is that greater than 6?
Yes.
Yes. So now we're going to draw it. So we want the first one to be, the base to be 6. All right, so once again, guys, I'm going to use my centimeters because if I use inches, I'm way off the page. All right, so there's my base. And it doesn't matter if I put my 4 over here or my 4 over here. Doesn't matter. Okay? Just remember you're going to have to play around with the slants of your lines. We know it works, so we should be able to draw it. So I'm going to put my 4 over here. And I'm going to slant it maybe like that. I don't know. And then let's see if I got enough room for 3. Yep. So I'm going to need to slant it some more, right? Because if I put my 3 there, you can see I'm not quite there. So I need to slant my 4 just a tad. So this would be my 4, and that would be my 3. All right, on B, my base is going to be 3.
I don't think that'll work.
It's got to work. Right?
But like the 6 was the base last time, so 3 plus 4 plus 3 was more than 6.
Okay, so what if I do this, Reagan?
Oh, I see it.
Is 3 my
I
base?
see. Okay.
Yeah, 3's my base, right? So basically I'm kind of creating like an obtuse angle. And then if I did it this way, 4 would be my base, right?
So we can just say all of these work, right?
Exactly.
I get
Exactly.
it now.
Yep. So let me finish this one. So this would be my 4. It's going to be pretty big, I think. Maybe not that big, but we'll see. So there's my 4, and then this one has to be my 6. Oh, I don't think I could have done that again if I tried. So 4, 3, 6. Okay? So yes, they will all work. Basically, all you're doing is just kind of changing the base. Right? But they're all going to work. So this would be a 3. And then this one would be a 6. So 6, 4, and 3. So then this would just be yes, yes, and yes. Anybody need any more time to copy them or draw them?
I do.
Okay. Let's move to D, E, and F. All right, so the question says, how are the triangles you made in part A through C alike? So it's what? The same triangle, just what?
Different base.
Yeah, just flipped, right? With different base. Okay? And then E says, complete the statement describing the relationship between the 3 sides of the triangle. So the sum of the lengths of the 2 shorter sides are?
Greater than.
Yep. Greater than the lengths of the longest. All right? Complete the summary of what you discovered. So if A plus B is equal to or...
Less than.
Yep, less than... The segments cannot form a triangle. If A and B is...
Greater than.
Yeah. Greater than C, the segment is one triangle. So I will tell you guys that on the test, I'm not going to ask you to draw the figures. What you're going to have to remember is that theorem, that inequality theorem of what makes true. Okay? All right. So let's look at the quadrilateral. Can you draw a quadrilateral with side lengths of 2, 3, 4, and 5? Make and use a model. Can you connect the endpoints to form a quadrilateral? If so, draw a quadrilateral. If not, explain why you cannot. So there's a rule for this one too. Anybody want to try the rule or think they know what it is? I can't hear you. Say it louder.
What, try stating it or what?
Yeah, what do you think the rule is for quadrilateral? If we add 2 of the angles and it has to be larger than the third, what do you think about the quadrilateral?
Can I try?
Yeah.
I'm gonna say that the sides have to equal each other out. For example, 3 and 2 equals 5, and 4 plus 5. Never mind.
Oh, well, that kind of makes sense. Yeah, who else? Jaden?
Wouldn't you have to have 2 pairs of equal sides?
Not necessarily. If you had 2 pairs of equal sides, then it would be like a parallelogram or something. Okay, so the rule, before we even look at it, is the sum. So once again, sum of the 3 shortest sides has to be more than the longest side.
What is this quadrilateral in
Is it? I don't know. Did you Google it?
No, I'm just guessing.
Yeah, I would probably say yes, but I haven't Googled it. Let's go back up here, though, guys, because I think this last statement is important. So on the test, they're going to give you some triangles, right? They're going to give you the dimensions of the triangles. And it's going to say, can you make one triangle, more triangles, or can you make a unique triangle? Can you make more than one triangle, or can you not make any triangles at all? So for this theorem, it says, if A plus B is greater than C, the segments form one triangle. So that's important to know. So if the theorem, when you add the two shortest and it's larger than the third, it will only create one triangle. Okay? It's different for a quadrilateral. In a quadrilateral, we can have a variety. And I'm going to show you what I've already drawn. That way we don't have to spend too much time drawing them. So if you can see, this was a 5, 4, 3, and 2, right? And then all I did was re-change the slants of my lines. Same lengths, 5, 4, 3, and 2. But as you can see, what changes are the angles in a quadrilateral. So the side lengths stay, but the angles change. So side lengths change, but angles, no, side lengths stay. I wrote that wrong. Angles change. Does that make sense? So that means I can have infinitely many quadrilaterals that I can draw. Because basically all I got to do is change the tilt of that line. Where if it is a triangle, I can only connect them, at those 3 points. So it's only going to form, as we, witnessed from this one, right? I showed you that all I had to do was just move it, and I would end up with that same triangle. Does that make sense? So let me put that there so you guys can see how I drew it and what I did. And then the turn and talk basically says, is it possible for the 4 segments, is it possible that 4 segments cannot form a quadrilateral? Well, yes. If the sum is shorter than the 4th side, then of course it won't do it. So you could do like 1, 1, 1, and 2, right? That wouldn't work. That would work. What if I did 1, 1, 1, and 5? Yeah. Something like that. Okay? All right, do we need more time on that one? Nope. All right, so the next page is really easy. It's just looking and using that rule to finish the statements, right? So if Nina has a triangle that is a 9, 8, and 11, will it work? So
yes, it'll work.
Yeah, it'll work because 9 plus 11 is greater than 15. So then that's what you're going to write here. Greater than. I couldn't spell greater, did I? And it can form a triangle.
Can I ask one question before we go on?
Uh-huh.
Because I'm writing down some of this stuff.
Okay.
For the quadrilateral, the 3 shortest sides have to be longer than the longest side, right?
Correct. When you add them together.
Okay.
So the sum of them has to be longer than the longest side. All right, so what about B, guys? What would I put?
Equal.
Equal. So does it form a triangle?
No.
So this would be equal, and this cannot form a triangle. All right, what about C?
No.
So this would be less than, right?
Less than cannot.
And then cannot. Yep. What about D?
5 plus 18 equals 13. So the one length that would work is 14.
Okay.
Above 14.
Right. So this is where we get those range of values, right? So it says 5 plus 8 is 13. So one side length that will make the triangle true has to be like 14, 15, and 16, right? Yeah, hold on one second, guys. Someone's at the door. You can put your mask on and answer it, Chase. Sorry, my son's here with me, so he doesn't know.
Son?
Who is it? Yeah, he has an orthodontist appointment today. Do what? Come here. Who is it? What do you want?
Ask if you need the computer card, bro.
I don't need the computer card, no. Okay, thank you. Okay, so 14, 15, or 16, right? So it says 5 plus 8 equals 13. So one side length that will make the triangle true
Is 12 inches.
Why 12 inches?
Wouldn't it be 12 inches because it's less than?
Wait, no. It'd be 13.
Well, it can't. So the third side can't be 13.
But that's equal to.
That
Because that equals to the no.
Right. So it has to be 12 because 5 plus 8 is greater than 12, right? And this has to be greater than the third side, correct?
Oh, okay, that makes more sense.
Okay. So what if I did 5 plus 8 is greater than 11? Would 11 work?
No. Yes.
Yeah, because it's greater than. Now, think of it this way. What if 8 is the third side? So what if I have 5 plus something and 8's over here?
Have 4 for the blank.
I would have to be 4, 5, 6, 7, something, in between those ranges, right? Does that make sense, everybody?
Yes.
Okay.
That was so confusing at first.
Yes. So that's what number 2, when you get to the check understanding, guys, that's what number 2 is asking you. What are those range of values? Okay? All right. We only have about 4.5 minutes. What does Jameer say? Jameer says it has to be 4 or more to be greater than 8. Yes. Okay, so what would happen is if you graphed it, you would probably have to do an inequality. So 4, 5, 6, 7, right? So this works. Is 7 included? And 4 is included, right? But 8 wouldn't. 8 is already there. And then we know that it would have to be what? 9? Would 9 work?
Yes.
Because 9 plus 5 is way more than 8, right? But 9 would become the longest length at that part. But it would still work because 8 plus 5 is more than 9. So 9, 10, 11, and 12 would work. But 8 wouldn't, right? because it would be 2 8s and a 5. Yeah, this one, it's hard to figure out those ranges, isn't it?
I have another question about the test.
Okay.
That's coming up.
8 would work
so,
too.
Is it gonna be like? Isn't it gonna be questions based off the triangle inequality theorem and the other quadrilateral theorem?
Yep. Yes. And I mean, we're only on 9-2, so then on 9-3, it's going to be, okay, now they're giving you a side and an angle. So what does that mean? And then they're going to give you 2 sides and an angle. And sometimes the angle is going to be what they call included. So it's included in the 2 sides, and then sometimes it's not included. So we're going to look at a variety of different things. Okay? So we're going to have a bunch of different constraints. All right, so we will check the check understanding. What is the shape that has a curve and sides? I have semicircle. I don't know what you're talking about. You're talking about this, something that looks like this? Yeah, that's a semicircle. All right, so we are just about out of time, guys. So we will check the check understanding tomorrow. And then tomorrow you guys are going to work on your own. Okay? Are there any other questions for today? All right, then if you have no other questions, you guys can log off for today. All right, and I will.
Bye, Miss Lavelle.
Bye, guys. I'll see you all tomorrow, okay?
Bye, Miss Lavelle.
Bye. Bye-bye, I guess. You're so funny, Xander. All right, why is this not working? All right, guys, see you tomorrow.